part A wants us to use the first derivative graph, which is given here in the dark black, and explain how it tells you about the directions and the key features of the original graph. So as you can see, the derivative graphs here, and the values that show the direction, whether it's increasing or decreasing in the original graph, are dependent on the sign of the values. So from -1 to 0, it is negative in the negative area, so therefore it is decreasing. And from 0 to 2, it's increasing because of its positive values. And same thing would work from 2 to 4.6, and which would be negative, and then 4.26 to 5, which would be positive because of its positive values. We also can see where the slope is 0 for the original graph, and that means that there's a possible max-min situation at those points, which would be 0, 2, and 4.26. We can also see that there's a maximum on this graph, meaning that there might be a possible point of inflection there. So how can we use the first derivative to find the information for the second? So we know that the derivative of a linear line is just a straight horizontal line, so we can find the slope of the linear line, which would be 2 over 1, so 2, and at the value 2, we just draw a straight line from -1 to 2. Now for the quadratic, we know that the derivative of quadratic is a linear line, so we know that at a max point there's going to be a 0 because the slope of the tangent line would be 0 there. So we can mark that and draw a linear line. So for C, they want us to sketch the graph of the, what does the second derivative tell you about the graph, the shape of the graph of the original? So whether the values are positive or negative will tell you whether it is concave up or concave down. So here the value is positive, therefore it's concave up. Then here it is negative, so it's concave down, and from here it's concave up. So then we can graph the original sketch, and we can draw number lines based on what we observed here, and you get the original graph that is concave down, concave up, and then concave back down, which follows the increasing decreasing pattern of the line graphs.